And welcome everybody. It's great to have you here for another Packet Tracer Lab. My name is Keith Barker and whew, I'm running a little bit late today. So our focus in this hands-on lab is to give you some practice implementing network address translation. Now we've had some videos previously in the master playlist right here on the Keith Barker channel regarding NAT and how it works. We've had some examples and demos, and this is primarily an opportunity for you if you want to get hands-on practice with Packet Tracer to go ahead and practice some network address translation. So without further ado, let me go ahead and line up a screen here, and let me share with you how you can get the Packet Tracer Lab, and then I'll download it from my site. So I'll be working with the same exact Packet Tracer Lab you are, and then we can go ahead and do the walkthrough of implementing and verifying network address translation. All right, so here is my desktop, and here's a little camera of me right there. All right, so this is the keithbarker.com, the website, and you can click on downloads, or you can scroll down, and here is, let me bring out a pen. Here is the Packet Tracer Lab right there. Let me move that out of the way. All right. Fun times. All right, this is it right here. This is the actual Packet Tracer. I named it, I'm just naming them the year, the month, and the day. It is the 12th. So whatever your religious celebrations are regarding this time of the year, happy whatever that is. So this lab right here, if you want to download it, I'm using Packet Tracer version 7.3. That's the question I get quite a bit, like what version of Packet Tracer? And the second question is, where do I get Packet Tracer? You get it from netacad.com. Sign in with a free login. Sign up for a free account, get a login, download Packet Tracer for free, and then you can download this lab and just plug it right into Packet Tracer and get some hands-on practice. So let's actually do that. Let me download this lab by clicking this down arrow, and it says, what do you want to do? I want to save it. Then we'll just go peek at my downloads folder, and there it is. Make sure it's lined up. Great, great, great. So let's unzip that. So extract all and extract. And there we go. So I've got a PDF. So in this PDF, it just has the details for the lab. But I also included the details for the lab in the lab itself. So you can either reference this or just open up the Packet Tracer file. I've already logged on to Cisco, so it's already asked me to prove who I am, which I've done with my username and password. And let me line this up. Give me just a moment to make it the right size for everybody. And that looks pretty good. Almost there. Almost there. All right. So the purpose of this lab is to give you an opportunity to get hands-on practice with network address translation. And if you need a backfill on what is NAT or PAT or how does that work, please check out the master playlist. And let's take a look at the objectives for this lab. They are right here. Download the lab file. Check. Number one, we did that. And the lab objectives are to leave the web and DNS server. That's this guy right here. This is the web DNS server. And let's see here. Leave the web DNS with no default gateway. So basically this web server, and if you look at its IP address in the lab, it's 23.1.2.2. That's its IP address. But it does not have a default gateway. So the reason I did that is that this could represent the public internet, where they're using globally routable addresses. And over here on the left-hand side, let me use a slightly different color here. Over here on the left-hand side, this could represent RFC 1918 addresses, which we are here in VLAN 10, which is a layer 2 construct, layer 2 VLAN 10. Associated with that specific VLAN, we're using the IP addressing scheme of 10.10.0.0 with a 24-bit mask. And for the other VLAN, which is VLAN 20, it is using 10.20.0.0 with a 24-bit mask. If you're brand new to IP addressing and masks and subnet masks and variable length subnet masking, check out our playlist called Subnet Saturdays. It's also part of the master playlist, and you can get right up to speed with all that. So here are the layer 2 constructs, the VLAN 1020. Here's the layer 3 IP addresses. In this lab, I'm not asking you to configure all that. We have other labs for that, including the one we did just a couple days ago. But what I would like to do here is we have a fully functioning network. So there's no troubleshooting on the inside network here. But this PC would like to be able to access that web server and also use it as a DNS server also. But the problem is this DNS server, this web server, doesn't know how to reach the 10 networks. It has no default gateway, and it can't get there. So the game we're going to play is bullet number 2 right here. And that is this. Implement NAT/PAT. Your choice. On the edge router, that's this guy right here. so that PC1 can open the web page of the server at thekeithbarker.com. So I've got a name record, a DNS-A record specifically for IPv4 on this server all ready to go. And it basically says, hey, if somebody's looking for thekeithbarker.com and they ask me for the IP address, I'll give them my own address. And then when the client makes a request to that server, it'll go ahead and open up the web page. Now the challenge is, again, this server has no clue about how to get back here to the private networks, and that's why right here on router 1, the edge router, we're going to implement network address translation. Now this video is premiering live here in about a very short period of time. That's why I'm going to make it nice and tight and concise. It's going to debut, and after it's on the web and after it's stored on YouTube, if you're watching this and you want to try it for yourself, this is the perfect opportunity to pause. Now in the live premiere, maybe watch the whole thing with me because I'll be there. But pause if you're watching this after the fact and download this packet tracer file, log in, and then work through implementing network address translation. Because in a few moments, I'm going to walk you through, one way of doing it. But if I just walk you through, if you have the experience or knowledge of how to do it, it would really be great if you applied those skills and reinforced those skills. Okay, so the spoiler alert warning has been given. Let's take a look at solving this problem. And here's my plan of attack. We could make a DHCP pool, and out here on this, whatever this network is, and assign addresses there because it's just in the lab environment. We can play with any free addresses that aren't in use. But I'm thinking, if this interface, gig00, already has an IP address on the 23 network, which it does, it is 23.1.2.1, why don't we just use PAT and overload on that interface and be done? We don't have to create a DHCP pool. And so we'll create an access control list. Now, am I writing on? Okay. I want to make sure I wasn't writing on my face. Don't write on your face, Keith. Don't write on your face. If we wanted to control who can be translated, we can use an ACL. Now, a common mistake that often comes up when we hear the word ACLs, filtering. Access control lists do a great job at identifying traffic. And if they're used as part of a filtering application where we apply it to an interface, we can have the ACL stop traffic. But we also have ACLs that can just identify traffic for the purpose of quality of service, giving some packets preferential treatment, like maybe a shorter line at the grocery store and telling, hey, you match this access control list, you get in the shorter line. That's what QoS is about, depending on how it's implemented. Or we could use an access control list to identify, hey, who gets translated? So we could say, with the access control list, anybody coming from 1010, or anybody coming from 1020, or anybody coming from 10 anything, all based on the access control identifying who can be translated, and then telling the router that this interface here, gig0/1, is the inside interface, gig00 is the outside interface, and then a rule that says if traffic is going in that direction, from in to out, and it matches the ACL, then go ahead and do a translation, and we'll just overload to the outside interface address. All right, there's our plan of attack. Let's go ahead and do it. So all the routing and all the switching and all the trunking is all in place. There's also HSRP running in this topology, which you can play with if you like. And let's go to the router. And I think we also feel free to play around in the lab and verify basic connectivity. But I believe basic connectivity is all working already, including, so I've got multilayer switch 1, multilayer switch 2, gig0/2, and these guys are doing routing, and the edge router is doing routing as well. All right, let's go to the edge router, and bring up a CLI, and we'll do all those things that we just talked about. So at the command line interface, let's do a show IP interface brief, just to make sure we've got addresses. So 0/1, which is going to be the inside interface, is 10.20.01, and gig00 is 10.23.1.2.1. Great. Just want to confirm which interfaces were inside and outside. Sounds good. And let's create our access control list saying that anybody on the 10 network who's going out can be translated. So we'll do show access list. I'm doing do because I'm in configuration mode. I don't want to have to jump out. Do show access dash list. All right, so that's a good place to start making sure you don't have an access list already, because big challenge is that we start adding access list and we are actually adding to an existing access list that we didn't realize was there. So no access list exists. We'll create access list 1, and we'll permit, and we'll specify anybody that starts with 10. That'll work. So 10, and then this is how we do the wildcard mask for that. That looks good. And we have a whole video on wildcard bits and wildcard masks and how that works. So check out those videos if you're interested in that. All right, so that's our access control list. Now we'll go to the interfaces and say, hey, Mr. Router Gig 00, you're the outside for NAT. Yay! And Mr. Gig 01 on the edge router, you're the inside interface. So they can know when traffic is being routed between those two interfaces, hey, okay, we might need to do NAT. We might need to do breathe. We might need to do NAT. All right, I'm excited. I'm excited. So we'll do a interface gig 0/0 IP NAT outside. I'm going to tab that out. Interface gig 0/1 on this edge router, IP NAT inside. And now we'll make a rule that ties it all together. And the rule looks something like this. IP NAT, and let me slide this over just a little bit so we can see it. IP NAT inside. I'm going to do inside source address translation. IP NAT inside source list 1. And that basically says, okay, traffic coming in from the inside. If it matches access list 1, you're a match. And then what do we want to do after that? And what we're going to do is we are going to map that or translate that. Instead of a pool, which we didn't set up, we're just going to go ahead and overload it on the outside interface. Interface, and that is, looking at my notes here, that's gig 00. Interface, gig 00. Whatever IP address is on there, that's what we're going to use. And we'll use the keyword overload so we can do this tens of thousands of times. A single IP address can handle thousands and thousands of internal addresses. There it is. Let's do a show IP NAT statistics. That's going to show us our interfaces involved. Huh. It's a little bit different here in... it appears a little bit different in Packet Tracer. That's okay. Let's do a show run. Pipe include NAT. All right, so I've got the NAT inside, NAT outside, IP NAT inside source list 1, interface gig 00 overload. All right, let's try it. Let's go to this PC and let's go out to the server. So you can just go out to, you can hover over the server, get its IP address, which is 23.122. Go back to the client, open up a browser, and we'll just do a one fell swoop. We'll troubleshoot if we need to. So we'll go to desktop, browser, and if it's working and we have the correct DNS server, we should be able to type in thekeithbarker.com. And that'd be so great if it worked. All right, a little bit of troubleshooting here. So let's back off of that. And let's go to a command prompt. And let's just make sure we have show IP. I'm on a Windows computer, or a simulated Windows computer. IP config 10.10.0.10. Default gateway is 10.10.0.3. Let's make sure I can ping my default gateway. All right, I can ping my default gateway. I'm going to see if I can ping this edge router. I'm going to hover over it. Its internal address is 10.20.0.1. Just verifying my connectivity through the network. 10.20.0.1. Oh, okay, great. I thought, okay, here we go. So I can hit the edge router, the internal interface. Let me see if I can hit gig 00 because the edge router has that address, and that is 23.1.2.1. All right, a little extra troubleshooting here. Ping to 23.1.2.1. Oh, unreachable. Awesome. Who's saying that? Okay. Oh, .11 is saying that. You know what? We get a little troubleshooting mixed in here. So we have these multi-layer switches that are performing HSRP and also routing for us. It appears that they don't have routes. So let's go to the MLS one, multi-layer switch 1. I apologize earlier. I said I thought all the routing was working. Apparently it isn't. Oh, look at that. A neighbor died. No, that's not good. Show IP interface brief. So I've got my VLAN 10 and VLAN 20 interfaces. Show IP protocols. I've got my routing protocol saying anything that starts with 10. Show IP OSPF neighbors. I've got neighborships. 22 is the last IP address of MLS2. So I've got full adjacencies here. Show IP route. Oh, I don't have a default route. Ah! All right. Okay, so basically what's happening is this was a NAT lab, but it's also now a routing lab because PC1 forwards the packet to the HSRP address, which is the hot standby routing protocol that's being supported by MLS1 based on the IP address that we saw, and MLS1 does not have a route out to the 23 network. It doesn't have a default route and doesn't have a specific route, so it's dropping the packet. Dropping it and also, fortunately, telling back to PC1, I can't get there from here. So let's find out why. So we have a neighborship between MLS1 and the edge router. We saw that if we do a show IP OSPF neighbor. So there's our neighborship right there. So why don't we have a default route? Well, let's go, let's see if the edge router is not advertising a default route. Let's do a show IP route static. Oh, it's got a static route. So it has a static default route. Let's take a look at the routing protocol. Show run section router. Look at that. Look at that. So R1 is being, let's talk about this for a moment. R1's being a little bit, greedy. It has a default route out to the internet or to the service provider address space, but he's not sharing it with anybody inside. So if we want our multi-layer switches to be able to route, they need to have either a specific route of how to get to the 23 network on the outside, or they need to go ahead and have a default route. So what we're going to do is we're going to tell R1, or the edge router rather, hey, default information originate always. Well, let's see if always is supported. But because he has a static route in routing OSPF configuration mode, we can do a default information originate, and we can have him originate or source that route for the benefit of his brothers. His brothers being the multi-layer switches. All right, so let's do that. We'll go to config T, router OSPF1, which is our existing routing process, and default information originate. And on a live gear, there would also be an option called always, which says, hey, advertise a default route, even if you don't have one. But we have a default route. It's a static route, so that should work. OSPF is very fast. We'll go back to switch 1. We'll do a show IP route. There it is, right there. We now have a default route advertised via OSPF because of the edge router. Let's go back to our PC. Whew. All right, let's do since we're here, let's do a NS lookup. It's a DNS tool, and maybe I should ask for something. Let's just do by. Oh, now it's trying to figure out what by resolves to. Asking the DNS server. That's almost as bad as the no IP domain lookup problem. Let's go back to the command prompt and let's do this. Oh, it's not letting go. Yeah, okay. Let's type in thekeithbarker.com. This is NS lookup in interactive mode. All right, so it's reporting back that address is 23.1.2.2. There we go. Exit's the proper way to get out. If you're an FTP, by would work. All right, now let's go ahead and open a browser. And we'll close the desktop app and we'll go to a browser and thekeithbarker.com. He shoots, he scores. Oh my gosh. Oh, wait. I don't have a page. Oh, there it is. Oh, there it is. Okay. All right. And to verify our NAT that should be happening. So the server thinks we're coming off of the local network because we appear as .1, the edge router. So we go to the edge router and just do a show IP NAT translations. HTTP uses TCP at layer 4. The default port is 80 for the requests. So we should see a few of those. There we go. So right there, I'll bring this over. This represents a translation for the web services. And this one here, the UDP port 53, is the well-known port for a UDP DNS request. It should be essentially a DNS UDP-based request on port 23. And so that is working. And if we did a ping, let's do that one last thing. And we go back to the PC, go back to a command prompt, and do a ping to thekeithbarker.com. So if we have the DNS already resolved in the local PC's cache, it won't make another DNS request. But if it hasn't cached it or the cache is expired, it'll make the DNS request with UDP port 53, and then it'll follow up with ICMP echo requests. All that should be shown in the network address translation on the edge router. Yeah, that looks great. We'll go take a peek while that's cooking. So here on the edge router, if we do a show IP NAT translations, we should have, I'll scroll up here. There we go. We've got some ICMP based on the ICMP packets, and we also have some additional UDPs that came in. And we can also clear those, clear IP NAT translations. Asterisk, wonk, gone. You don't want to do that in a production environment though, because the existing translations that were in place, if servers are responding back, all go away. All right. Well, I'm happy that we had that little extra bonus of routing, because oftentimes that's how networks go. We're configuring one thing, and then there's other pieces and parts that may or may not work. And in this lab, we had the opportunity to implement NAT, but we also had an opportunity to do basic troubleshooting of routing, because multi-layer switch 1 and 2, although they were running OSPF, they did not learn about the 23.1.2 network, and also they didn't have a default route. So thanks for joining me in this lab. I really enjoy this time we have together. After the premiere of this video, which is going to happen today in about 30 minutes from right now, I'm going to go ahead and be in that same premiere so I can answer questions. And then right afterwards, if you want to join us after the debut of the live premiere, we'll jump in the Discord server, and we can hang out in the voice rooms there and chat if you'd like, ask CCNA related questions, catch up and say hello. I'll have all those links involved in both the chats that we have during the premiere, and also in the discussion or the description down below, so you can get to the Discord server either way. I would very much like to thank you for your time and interest in studying and learning CCNA technologies at the beginning, for many of you, of your career in the world of IT. It's a good one. It's a good one. And I would like to be a little teeny part of that help in getting you to the point where you can understand, have the hands-on practice, and just crush it and just get better and better and better with whatever life throws your way. All right. Thanks, everybody, for joining me, and I'll see you in the very, very next video or live stream or whatever it happens to be online. Bye for now.